welcome back to KhemWithKess. Today we're going to talk about, again, addition of reactions for alkenes using oxidative cleavage, aka ozonolysis. I like ozonolysis for the most part. O3 is your function that you're using, so this is what you're looking for in order to complete this reaction. Yes, it'll have zinc and any other acid, but you need to memorize this as a whole in case one of the lines are blank. We'll start doing some problems really soon, but ozone has about 2 steps. Yeah, 2 steps. Your first step is you would analyze your beginning picture looking at all the alkenes. It does not mean you have to have multiple ones, but you may. When you see O3, what you're going to do as your first rule is you're going to cleave or cut the double bond in half. So what that means is I'm going to act like I have a pair of scissors and I'm going to cut each one of the double bonds right down the middle, just like this. So because even though the problem doesn't tell you that you have excess, you are still going to treat the problem as such. Once you do, the next part of this, I tend to tell students to kind of supersize the problem on purpose. So I want you to redraw the exact same picture. You're going to see me supersize it just on purpose. You're like, what is she doing? Because once you cleave or cut the double bond, you're going to then, I'll keep that underneath the same rule. I want you to separate them. So what I'm asking for is you to put a space in between. So let's do this. Perfect. So what we're doing is cutting right in between. Cutting right in between where we drew that line for each one. So it's like we have a gap pretty much in between. So I'm just going to extend the double bond here on both sides and just clean it up. Once you do that, now in step 2, you're going to add oxygens to both ends where you cleaved. Or where you cut. So for this one, the idea is I would put an oxygen on this side and this side because that was my actual cutting point was right here. So you do that for all of them. And you're done. I love O3. The purpose of O3 is to create carbonyl compounds. So what I mean by creation of carbonyl compounds is meaning that first, let's go back and just make sure we understand. Carbonyls are C double bond O's. We have different type of carbonyl compounds that actually have names to them. So when we look at this one that's hanging off of the end that has 2 hydrogens, this piece by itself, we would put a plus charge or sign right in between. This one is called a formaldehyde. They use that to preserve dead bodies. Cool fact. Then you have this structure here that is locked in between 2 carbons. So that one is what we would call a ketone. So I'm just going to point right here. That's a ketone. As we move through, we'll see that that carbonyl is connected to 2 carbons. So this is also a ketone. That's right here. Then when we look at the next problem, we see that down here, this carbon has 1, 2, 3 bonds. So that means it's missing one that we can't see, which is a hydrogen. You can draw it in to make your life easier. So this right here is an aldehyde. And then we'll just check the other two, being the last two on the end right here. So for the same thing, I would put a plus sign in between them because these are now two separate pieces. I would draw my hydrogens in if needed. And I will see that both of these are also aldehydes. So please memorize oxidative cleavage as being a simple step of taking some scissors, cutting the double bond in half, and adding oxygens on both sides. This is not the only form of oxidative cleavage, as we can also cleave with another reagent, which would almost keep the same two rules. However, a little bit more change is going to occur based off of the type of reagent that we're going to use. So remember, what are we creating here? Carbonyl compounds. And on the next slide, you will see that we will talk about the new reagent that can also do oxidative cleavage.